see and let's study our vector product. So first I discuss our vector product. We are taking 3D diagram, means three axes, x-axis, y-axis and z-axis, to understand about vector product. So this is x-axis, this is y-axis and this is z-axis. This is y-axis and this is z-axis. So we will take xy axis lies in this plane also, and z-axis lies perpendicular to the plane, like this paint. So how we can describe this? Take two vectors applying through x-axis and y-axis, or in this plane AB, two vectors. This is vector A and this is vector B. Vector B. They have an angle theta, so they are applied along with this plane. So the perpendicular on this plane represents its vector product. So the perpendicular, which is the plane perpendicular to this plane, represents this vector product of A cross B. So we write down A vector cross B vector in this way. Mod of A vector multiply mod of B vector multiply sine theta will be. How we can prove that there will be sine theta? So if we take a perpendicular from B vector to A vector, so this perpendicular distance and this vector, we have to take this vector applies as x-axis and this vector applies as y-axis. Then the perpendicular represent A cross B vector. We can take in this way also. This is anti-clockwise direction, so the thumb represents the A cross B vector, where A vector and B vector rotates anti-clockwise direction. So there will be sine theta. This perpendicular is represented by B mod of B vector multiply sine theta. So in this way A cross vector, B cross vector, A vector cross B vector can be represented. Now how we can prove that two vectors A cross B vector are parallel? The first property, property is 1. So the required condition to be parallel of two vectors, how two vectors can be parallel? So when two vectors A and B will be parallel, they have the angle 0 degree. So if sine theta is equal to 0 degree, then sine theta will be 0. Then we have A vector cross B vector must be equal to 0. So this is the required condition that two vectors are parallel or collinear, means they lie in the same line or they are parallel. So this is the required condition of being parallel or collinear. And if we used to know, here I have not introduced a unit vector also. Here the direction of this unit vector N cap is a unit vector. Unit vector. So in cross vector there must be a direction. So this direction can be represented through this unit vector, whose value modulus value is 1, but it applies on the perpendicular of these two vectors applied on a plane. Then the unit vector applies perpendicular to it, and two vectors are perpendicular to be perpendicular. So being perpendicular, we need theta is equal to pi by 2. Like if a vector applies through x axis and b vector applies through y axis, so they have an angle pi by 2. So here we have a condition that sine theta must be equal to 1. So if we put sine theta equal to 1, then we will get that the unit vector n cap will be a vector cross b vector by mod of a vector multiply mod of b vector. So its direction will be the same as the unit vector, and its value, this vector's value is a unit vector, which is n cap. Then we can say that the two vectors a and b are perpendicular to each other. The third property is that the two vectors, the commutative law commutative law does not hold in vector product. Commutative law does not hold in case of vector product. How we can prove this? It means that a vector cross b vector does not equal to b vector cross a vector. So we can prove this in this way, that a vector cross b vector's direction means here the rotation is anti-clockwise from a vector to b vector. This direction is anti-clockwise, and when we will take b vector cross a vector, the direction will be clockwise direction. The direction will be reverse in this way, or down of this plane, or below the plane, perpendicular below to this plane. So we cannot say a vector cross b vector is equal to, actually it is equal to minus of b vector cross a vector. This minus sign just changes the direction of the unit vector for a cross b vector, then it equals. So we cannot say that a cross b vector is equal to b vector a vector. So commutative law does not hold. We can take example of this. So before taking example, we have to see that we know that the three vectors of the axis along axis represented by I cap, unit vectors j cap and k cap. So here I cap, j cap, and k cap, k cap is equal to, here theta will be 0, so these are equal to 0. But if we take I, j or j, I k equal to 1, here theta is equal to pi by 2, so these are equal to 1. If we take an example that a vector is equal to x1 I cap plus y1 j cap plus k1 plus z1 k cap, and b vector is equal to x2 I cap plus y2 j cap plus z2 k cap. Then a vector cross b vector will be determinant form of I j k x1 x2 y1 z1 x2 y2 z2, and b vector cross a vector will be I j k x2 y2 z2 x1 y1 z1. From this we can say that these are not equal.
Ayo,